Hey there, it's Dr. Juice. I'm going to be giving you mind candy today. That means some interesting or intriguing idea that can maybe help you out in your life. We do this every day, so like and subscribe if you'd like to have more mind candy delivered to you every day. And today's topic is an interesting one. And this one, we're going to be talking about why AI, artificial intelligence, has seen such this amazing increase in capabilities recently. And by recently, I mean like 1 to 2 years ago. This is super surprising. So let's get into it. Maybe you can learn something from this. Learn a little bit about AI and enrich your knowledge some. So let's get into it. First, I want to go back in history some. Back to around 2012. At this point in time, that was about 12 years ago. A good amount of time. And at this time, there's this thing in machine learning called neural networks. We can think of the brain, the human brain, as consisting of neural networks, networks of neurons. Neurons have inputs, outputs coming into them, those being chemical compounds and electrical signals. There's some processing that happens within the neuron, and it sends out chemical compounds and electrical signals that go on to other neurons that it's locally connected to. We had some ideas in the machine learning community on how to replicate this basic idea via math, and we had this very, very simple implementation for it. You just treat every neuron as just some number. It takes as input some other previous neurons. The previous neurons input sum up. We sum them all up. Say you have like 1, 2, 3, 4 as inputs. That sums up to 10. And then we decide whether this meets a certain threshold. That's some number we arbitrarily chose. And based on whether it meets that threshold, we output 0 or 1 for that particular neuron. This is supposed to replicate the neuronal firing behavior in real neurons, where if they get enough activity from their inputs, you'll see the spike in voltage of the neuron. You can actually directly measure this if you have some slice of a rat's brain. I did this in a lab before. You just take this electrical probe and you can see real electrical spikes occurring in a rat's brain's neurons. Anyway, that was kind of what we're replicating with the neuron I just described for machine learning. You get enough inputs and it goes from a 0 flat line to suddenly a spike. We put a bunch of those together and maybe we can do something useful with it. We add a little bit more ingredients where the inputs to the artificial neurons can be weighted in some way. So you multiply each input by a particular weight. We can put some more modifications, such as instead of squashing it to 0 or 1, we can do other things. Maybe we throw away the negative values, but keep the positive ones. That's called a ReLU, which is used in artificial neural networks today. I digress. There's a lot more details I can go into, but to return to 2012. In 2012, we finally got something working with these neural networks. Before that, we hadn't really gotten anything useful. People had come up with all sorts of handcraft algorithms to like detect a face from a picture or something, and we didn't use neural networks. They weren't good enough then. But by this time, we had finally gotten something good enough to outperform everything. And we were able to classify a very large amount of images on something called ImageNet. This was, I think, millions of images, and we're able to outperform, I think we're able to get human level performance and identifying what these images were. And that was called the convolutional neural network. It's a little bit similar to what I described. I actually won't go into it. It would take a whole 10 minutes. But that was able to get us a big stepwise improvement in the capabilities of neural networks and artificial intelligence. There's a couple other key ingredients as well. We were able to make use of these things called graphical processing units, or GPUs. So in video games, to process the graphics, kind of like what you're seeing on screen right now with this 3D model that I have, GPUs can process lighting or particle interactions inside the game very quickly. They're able to do it in parallel. So there's many, many tiny operations that have to be done in a video game, and this type of hardware called a GPU lets you do those operations all at once, and we're able to make use of that technology for neural networks as well. So we're processing kind of each neuron of the neural network independently at the same time. This led to huge speed up. We're also able to take any arbitrary loss function. So this means like you want to reward your neural network in some way. With humans, that means rewarding a human based off something they want to eat. But with these artificial neural networks, we could just define some type of function as the reward function. And we have this new technology now where we can automatically adjust the parameters of the neural network. Those are the numbers the neurons have in it. Basically, you can think of a way like we can tune all the neurons in the network to produce this better reward value. So that was another key ingredient in 2012 in the performance of these neural networks. So we were able to get some pretty good stuff from neural networks. Then we're able to classify images. We're able to do other cool things like playing Atari video games and beating humans in Atari. I think at some point we beat players, like professional game players, in the game of Go, which was hard to do because Go is just a massive search space. There's so many moves that can be made in Go. We're able to do a lot of other cool stuff as well. We're able to do stuff like figure out proteins folding. So if you have some DNA code that translates to some 3D protein structure. After many steps, we're able to predict that 3D structure quite well. We're able to start generating sounds and so on. So these were all the advancements due to the ingredients I just described that originated in 2012. Incrementally, we got better over time as a research community, and we're able to do some of these cool products. But still, it was kind of still nascent, well known in the regular population about AI. We had some awareness of it within the regular population, but not so much as we do today, because 2 years ago we made another kind of stepwise improvement, 8 years kind of after the 2012 point, and that was something called transformers. This is a new neural network architecture that is able to do something called sequence to sequence mapping. That's where you take in some sequence of items and you output some other sequence of items, and you can train that in parallel. So prior to this, if you had some sequence like time-based sequence or order-based sequence, and you're predicting the next item in that ordering, you kind of needed to rerun your neural network over and over again for each sequence of items in order to get that next one. And you couldn't do any training on that neural network for that particular sequence-to-sequence mapping unless you had rerun it multiple times like that. And one thing transformers have done well is they make it so that you don't need to rerun the network over and over again to look exactly at the next item prediction. And this lets you train these transformers much more efficiently, again in parallel, on many large amounts of data. So that's one thing that was very good, important ingredient in recent explosion in AI. Another very important one is the use of something called self-supervised learning. And prior to this point, we had really seen the best performance in our AI based on labeled data sets. So that means human beings had gone through thousands of examples and hand labeled each of them, and then the neural network could learn. Instead, we did this little trick where we took our vast amount of internet data and we did something called self-supervised learning, where we can kind of get labels out of the data itself. So in the case of text, we can predict say we have a sequence of words, like 7 words in a sentence, and we're predicting the 8th word. Well, actually, we already have that label available. If we have like 100-word text, then we suddenly have 100 different labeled examples now. And we can do this for other things too. So like an image, if you've got an image is just a series of pixels, okay? And you can actually try to predict the next pixel, okay? So that can be self-supervised learning. Another thing that we have is we have text-to-image mapping. So if you go onto Google search results, you can search something, and it'll come up with images. Now we have some mapping from text to images. So we kind of came up with all these little tricks to create labels out of our basically unhuman labeled data, like our data that no human has ever labeled, but we have tons of it on the internet, and we kind of cheated a little bit and came up with our own labels in this way that way we could reuse the supervised learning, reuse the label-based learning that we had before without actually having to have the labels. So these were kind of like the main ingredients that led to this explosion in AI that we see. We also just threw a ton of money at the problem. I think OpenAI and Microsoft they've spent a lot of money to acquire, I think, millions of GPUs. The GPUs are quite expensive. So this is kind of what's led to an explosion in AI. Now today we have stuff like ChatGPT, which is able to predict text very well. We have these image generation models where you have some text to image mapping, and we're able to generate those very well as well. So we've really utilized the entire internet to bring about these great advances in AI algorithms. I personally am really excited and passionate to see what type of useful things come out of AI. I think we kind of overhype the current capabilities of AI. I think people are thinking these AI are going to turn into like Terminators or whatever. Really, our AI only knows some very strict, limited ways of doing things. In this case, it's just sequence to sequence mapping in some way. It's very interesting. I'd like to see where this goes. I think I'm personally very positive about it, given my expertise on AI and so on. I know for others it can be quite a scary thing, and that's okay. Anyway, maybe this history of AI has let you understand a little bit how we arrived at where we are today. I think to see more explosion in capabilities, we're going to have other big changes in our algorithms, such as what you saw in 2012 and such as what you saw in 2020. Who knows how many years it will be until we see another big step, but I'm carefully looking out for it. If I see something interesting, I'll let you know through this channel. Subscribe and like for more mind candy. Tomorrow, I'm going to tell you about some interesting idea that will either enrich your life in knowledge, provide you with something interesting, or help you out in your life in some way. So like and subscribe to view more daily content. I'll see you tomorrow.